Hello and welcome to another STEM in a Box video demonstration. My name is Dan Fleesick. Today's topic is rust. Specifically, what causes it? We all probably know that metal objects get rusty over time, and that can greatly reduce their strength and usefulness. Rusting is a huge concern for the Navy because the salt water that they operate in is very damaging to their metal ships. So we need to understand why rusting happens so that we can try to prevent it. Rust is something most people are very familiar with. You see it all the time on metal objects, especially things that stay outdoors like fences or barbecue grills. And tools too is pretty common. So here's a pair of old pliers that I have that are getting pretty rusty. So you can see, especially on the inside here, there's rust spots, and on the outside as well. So if I left this alone for long enough, it would eventually crumble down into brown powder and be useless. But what causes rust? Well, it's a process that actually needs three things. You need a source of iron, oxygen from the air, and water. So we can show that all three pieces are necessary with a pretty simple experiment. First, we need to prepare some nails as our source of iron. We're going to need a total of 6 nails for this experiment. They actually come with a thin coating of oil on them to protect them from rusting, but since we want them to rust, we need to get rid of that oil. And the best way to do that is with acetone. So all you need to do is take your acetone and dip your nails in there. And what this does is it dissolves the oil on the nail, and then you wipe it down a little bit with a paper towel, and you can see that gray. So that means we're removing the oils, and make sure you get all surfaces of the nail to get all of that oil off. And it shouldn't take very long at all. The acetone will dissolve it right away, and you'll be good to go. Now you might notice I'm not wearing gloves when I'm doing this. Normally, I always wear gloves in the lab, but in this particular case, it turns out it's not a great idea because the type of glove that I use is nitrile, and certain types of gloves are not recommended for certain chemicals. In this particular case, nitrile gloves don't stop acetone at all. They allow it straight through it. And that's not good. So in this case, it can actually be more dangerous to have a glove on because if the chemical gets on the glove, then it goes straight through the glove material, and now it's trapped against your skin. It can't evaporate. Acetone evaporates very quickly on its own, so if I get it directly on my skin just without any gloves on, it'll evaporate really fast before it has a chance to do anything. So in this case, I'm actually safer without gloves. And that's why it's important to do your research before you use any chemicals. You want to make sure that you're using the right protective equipment. A good safety resource to use for this sort of thing is this Ansel Chemical Resistance Guide. Mine's a little bit out of date, so I need to print a new one, but I think the information is still valid. So if we flip over to here, you see the different types of gloves up here, and then this huge list of chemicals. So let's see if we can zoom in for you. So the nitrile that I use is this second column, and acetone is right here, number 3. So if we go over there, you see we got NR for not recommended, and it's red. So nitrile, not a good glove for acetone. Some of these other ones are, like this laminate film or the neoprene, are pretty good. Laminate is probably really hard to find, but neoprene you can probably get at the hardware store. So that would be a better option. Now, if you don't have acetone, you can use steel wool instead. And actually, even if you do use the acetone, it's probably still a good idea to do this step 2, just to rough up the nail surface a little bit. Whenever you use steel wool, I recommend putting it on a paper plate or over a bowl or something like that to catch all the little fibers that fall off and just to prevent it from being a mess. See, there's already little fibers everywhere. So all you want to do with this is just kind of scrub the nail really well and make sure you get all surfaces, so both the head and the point. And that should remove any last little bits of oil and rough up the surface a little bit so that the rusting process can happen a little faster. Okay, now that our iron is ready, let's set up the experiment. We're going to use 3 different vials here, and each vial is going to have a different environment inside of it. Remember that rusting should require 3 components: iron, air, and water. The first vial, vial A, will have a normal environment that has all 3 of those components. So first of all, we'll add 2 of our cleaned nails to the vial, and that'll be our source of iron. And then we'll pour in enough tap water to cover those nails about halfway. And that's really all there is to that one. You can see the nails are now exposed to both water and air. And we're going to leave the cap off of this one just to ensure that air can keep getting in. And so that's vial A. In vial B, we'll also use 2 nails as our source of iron, and we're going to add water, but we don't want any air. So to completely eliminate the air from this, we're going to need to do a little bit of work to prepare the water. All water has some oxygen dissolved in it, which coincidentally is how fish breathe. So we need to remove that oxygen to make sure it's completely gone. And the way we do that is by boiling the water. This drives out all of the dissolved gases because gases are less soluble in liquids at high temperatures than they are at low temperatures. So this will get rid of everything that's dissolved and we'll just be left with pure water. And I'm also using distilled water in this one just because it's extra pure. If you can't boil the water, or if you don't have distilled water, that's fine. You can use regular tap water for this vial, but it just won't work quite as good. So first you want to bring the water to a nice boil like this. Then you want to take it off the heat and let it cool down. This is really important. So the vials that we're using are plastic. So if you put boiling water directly into the plastic vial, it's going to melt. So don't do that. You also want to loosely cover your container. So if you have a cap or a lid or something, just put it on very loosely. Don't screw it on tightly, because that, as the water cools down, it can make a pressure difference and it might crack your vessel. And what this does is it kind of stops the air from dissolving back into the water. Okay, now that the boiled water has been cooled down enough, it's ready to use. So again, we've got our 2 nails in this vial. So now we'll take this water and basically fill this vial up. We want enough water to completely cover the nails in this one so that there's no air available. Don't fill it up quite all the way because there is one more step. Because we need to form a barrier against air so that no more air gets back into the liquid. And to do that, we'll use vegetable oil, which comes in this little eyedropper bottle. So we just take the cap off. And I want to add enough vegetable oil to make a layer above the water here that's about 1/4 inch thick. And you can see the oil and the water don't mix. And it floats right on top like so. Yeah, that should be plenty. And then finally, we'll screw the cap back on nice and tight, just to ensure nothing else gets in. And so you can see the layer above the nails there. And finally, for vial C, we're going to have air, but no water. So normal air always has some water vapor in it. That's what they mean when they talk about humidity. And especially here in Florida, tons of water vapor. So we need to get rid of that. And again, we'll add 2 clean nails to this vial for our iron source. And now we'll need some of this, which is calcium chloride, specifically anhydrous calcium chloride, which means it doesn't contain any water. And this is a chemical that actually absorbs water. It's called a desiccant. And if you leave these little prills out on the countertop, they'll actually absorb so much water from the air that they turn into little liquid droplets. So they're very, very good at sucking up water. Anyways, we want to add enough calcium chloride to this vial to have about 1/2 inch of pellets. Maybe a little bit more. The exact amount really isn't crucial here. I think this will be plenty. And then we'll also need to screw the cap on this vial very tightly. That makes sure that no extra air is going to get back in. So now we have a sealed system, and the idea here is that the calcium chloride is going to suck all the moisture out, and we'll have just oxygen but no water. Also, when you're done, remember to screw the cap on the calcium chloride bottle nice and tight too, because we don't want this to absorb water and get all mushy. And there we have it. Vial A has iron, water, and air. Vial B has iron and water, but no air. And vial C has iron and air, but no water. Now, rusting is a pretty slow process, so I'm going to set these vials aside for a while, and we'll check back in on them later. In the meantime, try and come up with a hypothesis about how rusty you think each vial is going to be and why. Okay, 4 hours later, it's time to check in on our experiment. So it turns out vial A is rusting very quickly. You can see all of the brown at the bottom. The water itself is pretty brown, and there's even some rust spots like right on top of the nail there. There must have been a drop of liquid that was stuck there. So it's definitely rusting. Vial B looks like there's actually a small amount of rust. I can see on the head of that nail looks a little brown to me, and the water might be very slightly brown. So that is rusting a tiny bit. But vial C looks fine. I haven't seen any rust spots on the nails at all, so that's a pretty good sign. But yeah, you can see in B here, I think there's definitely a little bit of rust. But we'll have to see how it develops. So I'll keep an eye on these for the next couple of hours and get back with you when we see some changes. It's been about a day and a half now, and here's the progress on our experiment. You can see vial A is really rusty. The nails themselves have a nice fuzz of rust on them, and there's a layer of brown on the bottom. Vial B, still a little bit rusty. We get some kind of brownish color in the water, and there's some definite spots on the nails. But vial C looks totally fine. I don't see any rust at all on those nails. So this one turned out very nice. Okay, it's been a little over 2 days now, and things look about the same that they did yesterday, so I think we're far enough along that we can draw some conclusions. We see that vial A is extremely rusty. This is the one that had all three components, the water, the air, and the iron. Vial B, we've got a little bit of rust, not quite as much as A. That was the one that was supposed to exclude air and only have water and iron. And this last one had just air and iron, and there's definitely no rust on there. So just in case you get a little bit better view on that. So I don't see any rust at all on there. So removing water appears to be a very effective way of preventing rust. Now I think this middle one rusted a little bit, probably because I didn't prepare my water thoroughly enough. So maybe I need to boil the water for a bit longer to ensure that all of the dissolved gases are driven out. But that's how science goes sometimes. You get results that are a little bit different than what you expect, but that's a good thing in science because now we can ask more questions, and I can try a new experiment where I boil my water for longer and see if that's enough to protect it. So hopefully this experiment showed you that rusting is a process that requires both air and water to happen at a reasonable rate. I hope this video has helped you to understand the rusting process. Thank you very much, and we will see you next time.